Alright, in this lesson we will practice solving radical equations that are a little bit more complex, including equations that have fractional exponents on the variable. So, let's get started. Okay, so the first thing we need to know is focus on the variable. You know we're going to have to get this by itself. So let's definitely subtract 15 from both sides of the equation. So that's going to leave us with x to the 2/3 power is equal to 9. So now we want to get the variable by itself. So here's the trick that we're going to be using. To get rid of this fractional power, we are going to fight fire with fire, which in this case means we're going to eliminate a fractional exponent with a fractional exponent, specifically the reciprocal. So if I have the 2/3 power, imagine that if I raise this to the 3/2 power, what's going to happen? Now, first of all, before I get too carried away, this is a legal move as long as I do the same thing to both sides of the equation. Now remember, when you raise a power to a power, you multiply. So I'm going to wind up multiplying these two together. But look, when I multiply these two together, the 2's are going to cancel out and the 3's are going to cancel out. So it just makes 1. So basically that's gone. So that's just going to leave us with x equals. Now we have 9 to the 3/2 power. Now, it's been a while, but please remember, because just in case you do not have access to a calculator, which is a very real possibility, you should be able to evaluate this without a calculator. When you have a fractional power, what you're looking at is power over root. Power over root. Okay, so this is the second root. In other words, we're talking about the square root of 9. 3 is the power. Oh, you know, that 2 is understood. Don't put the 2. When it's the second root, you just leave it empty. But anyway, 3 is the power. So that's going to go out here like that. So you don't need a calculator to simplify this. Are you crazy? The square root of 9 is 3. So that just becomes 3. So now I have 3 to the 3rd power. Okay, I mean, I know this in my head. 3 to the 3rd power is 27, so that's going to be the answer. But what if you did not know that 3 to the 3rd power was 27, and you did not have access to your TI-30XS multiview? Well, one thing that I will give you is a table. So you can read off the table. Maybe I should zoom in. So here's the base of 3, and if I want to raise it to the 3rd power, that gives us 27. Okay, anyway, so that is the answer. And just to be on the safe side, you should substitute it back in for x and make sure it makes a true statement. Alright, I guess I'll do it just this once. But in the future, I will leave you to do this check by yourself. So, but let's do it one time. One time. Stay with me. If I want to check x equals 27, then I'm putting 27 here. So this becomes 27 to the 2/3 power plus 15, and I'm trying to verify that that equals 24. Remember, power over root. So this 3, that's the cube root. So that means we're talking about the cube root of 27. And then 2 is the power, so that's squared. Plus 15 is equal to 24. Now, the cube root of 27 is 3. Okay, so that leaves me 3 squared plus 15 equals 24. Again, if I want to do the cube root of 27, I'm working backwards. I'm doing the cube root of 27 is 3. It's going in the other direction. And of course, 3 squared is 9. So that gives us 9 plus 15 is equal to 24. And 9 plus 15 is 24. So 24 equals 24. Okay. It's not a very smiley face. That's better. Okay, so it checks out. I'm not going to do that every time. You get the idea. You do it yourself next time. Alright, take a look at number 2. You cannot distribute the 3 because we have this exponent here. So instead, we have to get rid of the 3 using division. So we need to divide both sides of the equation by 3. That way, hopefully you'll see that these 3's will cancel each other out. And, oh wait, I forgot to do the 3 over here. Silly Burton. So that's going to leave us with x plus 1 to the 4 over 3 power is equal to 16. Now, if you did not know that in your head, and you're saying, well, what if I'm not allowed to use a calculator? Well, you will be allowed to use a 4-function calculator, just not your precious TI-30 XS Multiview. I'm sorry, I got carried away there. Anyway, if I want to get rid of this fractional exponent, I can get rid of it with another fractional power. So what I could do is I will do the reciprocal power. So I'm going to do the 3 over 4 power to both sides of the equation like this. Now on this side, the 4's cancel, the 3's cancel, so I'm simply left with the x plus 1 part. Now over here, I've got 16 to the 3/4 power. Remember that this is power over root. So I'm talking about the 4th root. So let's start with that. So I've got the 4th root of 16. And then 3 is the power, so I'm going to put that out here. So 4th root of 16. Now I happen to know what that is off the top of my head, but let me pretend like I don't. If I want to do the 4th root, then I look at this column. Alright, so the 4th root of stuff is, the first column here. So I want the 4th root of 16. So I go to this column and I go to 16. 4th root of 16 is 2. So that's how you use that chart, which will be given to you. So that gives me 2 to the 3rd power. So I've got x plus 1. Now I know what this is in my head, but if you didn't, then you will go 2 to the 3rd power is 8. You'd have to do it that way. So I'd have 8. And then I would subtract 1 from both sides, so I'd get x equals 7. Okay, so this is the answer unless it is extraneous. Alright, so I'm going to leave it to you to check this answer by plugging 7 back in, following through, make sure that you really get 48. But you do. So make sure that you do. Now, number 3. If I want to solve this, I need to get this whole variable part and the radical part alone first. So I'm going to add 13 to both sides. Okay, so that is going to give me, so I'll have the 4th root of 2x equals 4. Okay, now that I have the radical alone, this is the 4th root, so what I can do is the 4th power. So I can do the 4th power to both sides like this. Now on the left side, the 4th root and the 4th power are inverses. They cancel each other out and just leave 2x. Now over here I have 4 to the 4th power, which I think is 256. So 4 to the 4th power is indeed 256. Okay, you can get that right off the table. 256. Now to get the x, I need to divide both sides by 2. That was weird. Okay, so let's divide both sides by 2. These 2's will cancel out. So I'll be left with x equals. Okay, I could figure out what that is, but I choose not to. 256 divided by 2, 128. Perfect. Okay, and that is probably the answer unless it is extraneous. So you should look back and make sure it's all copacetic and you really get -9. But I have a very strong feeling that this works out just fine. So I will leave it to you to plug this back in and make sure that you really get -9. Okay, for now I will move on. Alright, now take a look at number 4, my good people. By the way, pause the video. You know, I've done several problems, and I meant to say this every time, but every time I start a new problem, you should stop the video and try to do the problem by yourself first. Okay? Because that's when the best learning happens, not by copying off of me. Silly goose. So we need to get this radical by itself. So let's subtract 10 from both sides. So that's going to give us the square root of 6x minus 5 is equal to -7. Okay, so next, to get this, to get rid of the radical, we would square both sides of the equation. Okay, so we're going to square this side, we're going to square this side. Okay, so on the left side, that does make the radical go away. So that'll give us 6x minus 5 is equal to 49. Okay, -7 times -7 is positive 49. And I would continue on solving this. So plus 5 on both sides. So that's going to give me 6x is equal to 54. And finally, I divide both sides by 6, don't you know? And I know that 6 goes into 54 9 times. So that gives me x equals 9. So I'm thinking that's the answer. Yay! But wait just a minute. Alright, this time I am going to plug this back in to make sure this really works. I have a suspicion that it does not actually work. After I test my hypothesis, I will tell you why I had that suspicion, so you can share my suspiciousness. Anyway, if I put this 9 back in, so I am performing a check. Okay, I'm checking x equals 9. Okay, so that would make this become the square root of 6 times 9 minus 5 plus 10, and I want to make sure that that equals 3. Okay, so that's 54. So I've got 54 minus 5 plus 10 is equal to 3. Okay, 54 minus 5, that's 49. So I've got 49 plus 10 is equal to 3. Square root of 49 is 7. So that's, uh-oh, what is going on here? 7 plus 10 is 17. That does not equal 3. No. So that means 9 is not a solution. So we have to throw that out. Alright, the word for a wannabe solution that doesn't actually work is called extraneous. Alright, Mr. Burton, do we have to know that word? Yes. Mr. Burton, what if we spell it wrong? Will we lose points for that? Yes. Okay, this is not English class, Mr. Burton. Too bad. Cross curriculum. Okay, you have to learn how to spell a handful of mathematical words. Deal with it. Anyway, got carried away there. So that's extraneous. And because that was our only solution and it turned out to be extraneous, what do you think we're going to say for the final answer? We're going to say no solution. Okay, now let me share with you why I was suspicious that it was going to be extraneous, so you can be suspicious right along with me next time. It was way back here on the second step. Okay, it was right here. So let me erase this pink part. Okay, so really focus your eyes on this. Maybe I'll put a box around it for a second. Okay, to really draw the eye. Okay, so if you focus on this, we have the square root of 6x minus 5 equals negative 7. Okay, why should this be bothering you right immediately before you do anything else? Why should this be bothering you? Well, we have the square root of some stuff, okay? Now think about it. Maybe I'll do this off to the side a little bit. Let's see, this calls for a new color. If I have the square root of question mark, and that's going to equal a negative number, what could I put in here that would make this a true statement? Well, I know the square root of 49 is 7. Alright, that's close, but I want a negative 7. Okay, so that's close, but no. How about the square root of negative 49? Is that going to give me negative 7? No. If you take the square root of a negative number, you don't get a negative number, you get an imaginary number. So that would be 7i. Okay, so if 49 doesn't give me negative 7, and negative 49 doesn't give me negative 7, what could go in here that's going to give me a negative number? And the answer is nothing. There's no number I could put in here for this question mark. You can't take the square root of something and come out with a negative number. So as soon as I see the square root of something and it's equal a negative number, I know that's going to be no solution. Alright? There's nothing that can make that true. It's the same thing when I have something squared. Okay? Like if I have something squared and that's equal to a negative number. Even if I make it a perfect square, like 16. What could I put in here that's going to give me negative 16? Nothing. Because if I square anything, it's going to turn positive. Okay, so if I see something like this, as soon as I see this, I know, wait a minute, no solution. When I see this, I immediately know it's going to be no solution. So when I saw the square root of business equals negative number, I immediately knew that it was going to end up being no solution. Okay, take a look at number 5. We must be very careful. To get rid of this radical, I definitely want to square both sides. Okay, so I want to do that. But when I square the left side of the equation, understand that I'm squaring a binomial here. I can't just square the parts. I need to multiply it by itself. So x minus 12 squared means x minus 12 times x minus 12. Now the right hand side is simply 16x. But over here we're going to have to double distribute or FOIL or whatever you want to call it. So x times x is x squared. Okay, outer I have negative 12x. Inner I have another negative 12x. Put those together, that's negative 24x. And then negative 12 times negative 12 is positive 144. And that equals 16x. So I need to solve this for x. Let's get 0 on one side and either factor or use the quadratic formula. So we would subtract 16x from both sides. Okay, so that's going to give me x squared. Let's see, this looks like minus 40x plus 144 is equal to 0. Now, I'm going to try to factor this, but if I don't see the answer right away, then I'm going to use the quadratic formula. Alright, it wasn't immediately obvious to me when I looked at it, so I'm going to go ahead and try to solve this using the quadratic formula. Okay, remember what the quadratic formula is. Let me put that off to the side. The quadratic formula was like this. x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if you have not memorized that yet, you better do it because you're late. You're really late to that. So the part under the radical here is called the discriminant, and we always find that first. So let's do that right now. Okay, so the discriminant. Alright, the discriminant, b squared minus 4ac. So this is b right here, and a is 1, by the way. So b squared, so negative 40 squared, minus 4ac. Okay, that's a, that's b, and that's c. Notice my use of parentheses around this negative 40. Okay? So let's see. So that's going to be negative 40 squared. Okay, minus 4. I don't really need to put the 1. And then c was 144. Okay, 1024. That's my discriminant. 1024. So now that I have the discriminant, I can go ahead and do the rest of the quadratic formula. So the quadratic formula is x equals the opposite of b, so that'll be positive 40, plus or minus the square root, and we already found the discriminant, so it's 1024, all over 2a. So 2 times 1 is 2. Okay, let's just evaluate the square root of 1024 real quick. So square root of 1024 is 32. Okay, that was a perfect square. So I get x equals 40 plus or minus 32 over 2. Okay, so we can turn this into two regular answers, okay, by splitting this up. So we're going to get x equals, and we're going to do 40 plus 32 over 2, and we're going to get 40 minus 32 over 2. Okay, so 40 plus 32, that's 72 over 2, and well, I'm running out of paper, so that is 36. 40 minus 32, that's 8 over 2. Okay, so that's x equals 4. Okay, again, you should be able to do all of this using no more than a 4-function calculator. Alright, so these are our two potential solutions, but maybe one or both of them are extraneous. So let's look back and make sure that they actually work. Okay, so let's see. Looking at the 36, for example. Okay, if I do the 36, this is looking like it's going to be fine. Okay, let me just do a check right in this area right here. Okay, so let's check x equals 36. Well, that would make 36 minus 12 is equal to the square root of 16 times 36. Well, 36 minus 12 is what? 24. Okay, yeah. Meanwhile, over here, 16 times 36, and okay, even on a 4-function calculator, 16 times 36, that's 576. 576. Okay. Now, I think even on the small calculators, I can still do the square root of 576. So let's do that. So if I do the square root of 576. That is 24. So I get 24 equals 24. Okay, so that worked out just fine. Okay, now let's check the other one. Alright, so let's check the 4. I think I'll switch over to purple. No, I'll do pink. So let's check x equals 4 and see what's up. If x equals 4, then what we have is 4 minus 12 is equal to the square root of 16 times 4. I already see a problem. Because 4 minus 12, that's a negative number. Okay, that is negative 8 equals. Now, it doesn't really matter what this is, but 16 times 4, okay, just to be thorough, is 64. Alright, but there's nothing you're going to take the square root of that's going to give you a negative number. Okay, so you have negative 8 over here, but over here you have a positive 8. Wah, wah. That is a fail. Okay, wait, I should have made that box big enough to include the word no. Maybe I'll write it off to the side. No. So, x cannot equal 4. Alright, 4 is extraneous. So, we'll come back down here and throw that one out. That is extraneous. Okay, learn how to spell this word. So that means x equals 36 is our one and our only solution to problem number 5. Alright, number 6 will be the last problem on this video. So again, stop the video and try to do problem number 6 by yourself first. And then hit play and see how you did. Alright, this radical is already by itself. So as we've done before, we should go ahead and square both sides. That will make this radical go away. So that's going to give us x squared plus 5. Meanwhile, over here, you can't just make x squared plus 9. You can't just square the pieces. You have to do x plus 3 times x plus 3. And you're going to have to double distribute or FOIL or whatever you want to call it. So that's going to make x squared. And then x times 3 is 3x. 3 times x is another 3x. 3x and 3x. Okay, that's 6x. And then 3 times 3 makes 9. So we have this nice trinomial. So over here I've got x squared plus 5. Now, so the next thing we would do is try to get some of these like terms together on the same side. But when we try to subtract x squared from both sides, look what happens. These cancel out and these cancel out. So no more x squared. So that leaves me with 5 is equal to 6x plus 9. So we keep going. Now let's subtract 9 from both sides, trying to get x by itself. So that's going to give me negative 4 is equal to 6x. Time to divide both sides by 6 to get x by itself. Alright, so that gives me x equals, alright, because these 6's cancel out. And this will reduce to negative 2/3. So this is likely the answer. But we definitely need to check and make sure that this is not extraneous. Okay, it's a little bit difficult, but let's do it. So negative 2/3. I think I might cheat a little and use my TI-30 just because I'm in a bit of a hurry. So we have negative 2/3. See if I can squeeze this in. So if I put that in here, I would have negative 2/3 squared plus 5, and that's supposed to equal negative 2/3 plus 3. Okay, so this will be a little bit of a pain to do by hand, but what are you going to do? Sometimes you got to do what you got to do. So when you square this, let's see what's going to happen. First of all, when you square something negative, it turns positive. So forget about the negative sign. 2 squared is 4, and 3 squared is 9. So this becomes 4/9 plus 5. Okay, and so you could think of this as like 5/1 or something. And we have negative 2/3 plus, and this is like 3/1. But we need like denominators. So in here we need both of these to be 9. So we'll do that. Over here we need both of these to be 3. Squeezing it in. Okay, so that's going to make, okay, like denominators. So so I've got 4 plus, and 5 times 9, that's 45. Okay, common denominator. Over here, alright, I've got negative 2 because of that, and then plus 9. Okay, and we've got this common denominator of 3 now. Okay, this is an ugly problem to check anyway. So this is 45 plus 4, so that is 49. Okay, over 9. And okay, and this is equal to negative 2 plus 9, so that is 7 over 3. Interesting. Are these equal to each other? Well, let's keep going. As we simplify on the left side here, the square root of 49 is 7, and the square root of 9 is 3. So we have 7 over 3 equals 7 over 3. So that does work out. Okay, so that was my check. X equals negative 2/3. Alright, so it did check out just fine. So that means negative 2/3 is the solution to problem number 6. And that's going to be it for this video, my good people. If I have time, I will make a second video for the other half of this worksheet, but no promises. 6 problems might have to be enough for you.